Good evening. It is Sunday, and this is the second installation of our architectural hand drafting tutorial. Last time we reviewed the tools we would need and had a basic overview of how they are used. That episode is available on my second YouTube channel, the address for which is shown in the corner down here. This time, we will cover getting measurements of a building from which to create plans, which are the top-down view of a building at a specified level. It's basically like making a horizontal slice through a building, lifting off the top, and looking down at the interior from above. This has applications beyond just architecture. It is also useful for game design. You might ask why we are starting by measuring and making a plan of an existing building. First, because that's how the curriculum went in my first drafting class, and I am reviewing. Second, at some point, you will be designing something for an existing building, and you cannot trust that there will even be plans for it on file anywhere, much less that the plans will be accurate to the building's current state. Yes, people are supposed to submit plans to the Planning and Zoning Office to get their building permits. But if the plans change in non-load-bearing ways, they may not update their submitted plans. And people also frequently forget to submit plans and get a permit for remodeling, especially if they are doing the work themselves, which means that even if the building started out accurate to the official plans, subsequent changes may not have been recorded. You need to know how to measure and recreate, on paper, in scale, the building you're working on. This will enable you to accurately tell the builder what needs to be demolished and what needs to be built. Third, if you haven't had any previous practice estimating distances and areas, measuring a building or room will develop within you a better sense of how large a space is when you are designing a new one. A 10 by 10 foot room containing a single treasure chest and an orc wielding a spear seems large until you try to fit more than one adventurer in it as well. So, getting measurements for a building. You will need a tape measure, preferably one that is longer than 30 feet, though a 25-foot tape measure will work well enough, a pencil or lead holder, and a sketchbook or clipboard with paper on it. This is what a tape measure looks like. It has a metal tab on the end for hooking on outside corners, and a slide lock that will keep the tape from retracting into the case. These are both useful features, especially when you are measuring things alone. The basic division is in inches, with marks for ½ inch, ¼ inch, ⅛ inch, and 1/16 inch. You don't need anything more precise than that for this task. Tape measures also have marks every foot and every 16 inches. Why 16 inches? Placing wall studs at 16 inches on center is standard practice for most wall framing in the United States. The basic module for wall materials like plywood and sheetrock is 4 feet by 8 feet, and 12 and 16 inches both divide evenly into 4 feet. If you are using a metric tape measure, there will likely be similar marks at whatever distances conform to local building standards. The first impulse of most beginners is to pick a corner and start measuring from it, adding a new line for each wall corner as it goes along. The problem with this method is that your lines will not be proportional to each other, and whatever you get down on the paper will be misshapen and disconnected. This is not conducive to recording all the measurements you will need. Why not use your scale when you're measuring a building, you ask? Hypothetically, you could, but that's one more object to juggle when you only have 2 hands and they are already occupied with your tape measure, your pencil, and your drawing pad. You're also not likely to be able to put the scale at exactly the right angle anyway, which will still result in a disconnected drawing. And if you want to get really technical, a scale is for putting down measured marks. It is not an inking or pencil edge and should not be used as one. This is the better way. First, make a rough sketch of the elevations, that is, the vertical face of the building you wish to measure. If you are measuring the entire building, you will need all of its elevations. If you are measuring only part of a building, you will need as many elevations as encompass the portion of the building relevant to your project. In this case, we are measuring the entire building, so we will need a sketch of all four sides, like these. We have the east, north, west, and south elevations. This is the east side of the building, the north side of the building, the west side of the building, and the south side of the building. This is not a perspective drawing. An elevation shows all the vertices, that is, the corners, on one side of a building as though they were flattened into a single plane. I have sketched the east and west elevations and the north and south elevations on top of each other so that I can run reference lines to make the width and length of each building consistent between drawings. If you would be interested in a sketching tutorial, let me know. Make sure you leave plenty of room between the pairs so that if you forget part of the building like I did right here, you can still add it in afterwards. Once you have your elevation sketches, use them as a reference to create an outline of the building. The first thing to do is draw the largest extents of the building. These should be proportional, more or less, to the elevation sketches. Here's what I mean. Using a finger and the lead holder as a gauge, we can see that the length of the building is approximately 2¼ times the width of the building. The building is a rectangle, basically. So we will start by drawing a rectangle which is more or less twice as long as it is wide. It's close enough. Once we have our major extents, we can refer to the elevations to refine the outline. We can add bump outs. Oops. Take off corners. Mark where windows and doors are. Based on what we sketched on the elevations. For purposes of this lesson, we're just going to sketch a plan for the basement. Once we have a sketched plan, then is the time to go out and measure. The sketched plan will likely not be entirely correct or entirely proportional, but as long as you have all the necessary features, you will be able to take a measurement of them and correct the proportions on the scaled plan. Measuring will be infinitely easier if you have a second person to hold the end of the tape. You can still measure if you don't have a second person, but we'll have to make sure that the end of the tape is securely hooked onto a corner. So pick a corner of the building and draw your measuring tape out to the next corner. Record the measurement on your sketched plan next to the line which corresponds to the wall you're measuring. Continue around the building until you have measured the entire perimeter. Ideally, you should measure the entire length of the side of the building and then go back to measure for doors and window openings and for the additions, bump outs, and porches. This is not always practical, so you can also measure from the corner to the next window, to one side of the window, to the other side of the window, to the next corner, and so on. This latter method is likely to produce less accurate measurements, but sometimes that can't be avoided. For greatest accuracy, you should hook your tape in one place and mark each window or door opening with the distance from the 0 point on the tape. Once you have your measurements, add all of the measurements for the parallel planes of a given side Sorry, I lost my place. Add all the measurements for the parallel planes of a given side of the building so that the sum of the individual measurements matches the overall dimension, and to make sure that the measurements for the parallel faces of the building are at least close to each other. If you had to measure the face of the building in parts, this will allow you to check those measurements against the measurements of the other walls. You can see here that the totals do not match. By my measurements, the south elevation is 17 inches shorter than the north elevation, and the east elevation is 4 inches shorter than the west elevation. If you get these results, it may mean that your measurements are inaccurate. You can and should try measuring again just to make sure. However, it is also possible that your measurements are accurate and the building is just that far off square. If the foundation was laid crooked, the rest of the building has no choice but to follow it. Now that everything is added up, you have all the information you need to start drafting your scaled plan. We will start on that next time. This video will be available on Twitch for the next 7 days, and will shortly be available on my second YouTube channel at Featherblade000, shown in the corner here. If you have any questions about this lesson or the previous lesson, please feel free to leave a comment on the video on YouTube, and I will answer it as best I can, either there or in the next drafting video. Special thanks to my stepdad for letting me talk through the measuring instructions with him until they made sense. Thank you very much for watching. I appreciate your company. Have a lovely week. Good night.